All right, in this lesson, we are going to be talking about limits at infinity, so which is different than an infinite limit. We're going to be really talking about what happens as the graph goes to the right, i.e. when we're plugging in x's that are getting infinitely large, what's happening to the y values? Are they approaching a certain thing? Are they going up forever, down forever? Basically, we're talking about end behavior. So on this graph right here, as x approaches negative infinity, our y values are approaching a very specific y value of L. And then as x goes to positive infinity, our y values are approaching M. So we can have different values. We could have the same thing, but just kind of depends. So our limit as x approaches infinity of this f of x, which just basically means as the graph goes to the right, we're approaching L. So we can equal a value. So it's in the end behavior, totally the same idea. We're just going to fancy it up a little bit. All right, so if we're looking at these two problems, first one is, remember the whole idea is that we're going to be plugging in infinity or a limit. We're going to be plugging something in at some point. We're going to be doing the same thing, so we're going to have to kind of logic our way through this a little bit. So when we're talking about something like this, we have a property that we can take our limits and we can break them up, which is kind of what we need to do. So we're going to break this up and treat it independent of the other piece of the 10 over x squared. All right, so this one, the limit as x approaches, as x goes to negative infinity of 2, 2 is just a constant, so it's just going to stay at 2. And then over here, if we were to actually plug that in, we would be taking a negative infinity, so negative large number and squaring it, but we're taking 10 divided by that. So if you're taking a value divided by something that's going to infinity, the important thing is that it's a positive infinity, is we are going to be getting, well, it doesn't matter in this one, but we're going to be approaching 0, right? Something divided by something that's ever increasing, we're going to get a 0. The idea is that we're getting 0 from either above or below, but the main thing is that that's going to be adding up to 0. So our overall limit or end behavior, if we were to graph this, would be as the graph goes to the left, we are approaching 2. Right? So if we take a look at this problem, we'll do the exact same idea. The limit as x approaches infinity of 5 plus the limit as x approaches infinity of sine of x over square root of x. All right. This one, I think I can kind of logic my way through it, but you do have something that's going into an infinity on this, and then you're divided by something that's in infinite. So I think I have an idea, but let me show a little bit of a math to justify it. This thing, I believe, is going to be going to 0. All right, but let me show you why. That if we take a look at the top, sine doesn't go to infinity. So if you keep on plugging in values, it oscillates, and it's going to range between a -1. So this sine of x is going to range between a -1 and a +1. And so we're going to use the squeeze theorem to kind of really justify the fact that I believe this thing is going to go to 0. So what we'll do is we will multiply everything by a 1 over square root of x, which is really just we're going to divide every single thing by a square root of x, because that's what that is. It's in the denominator. So this is going to become a -1 over the square root of x less than or equal to sine x over square root of x less than or equal to 1 over square root of x. All right, so now if I start to do some limits on these, and I do the limit as x approaches infinity of a -1 over square root of x, I know that this is going to take a -1 divided by something that's getting infinitely large is going to be approaching 0. I know the limit as x approaches infinity on the outside, 1 over square root of x, that one is also going to be approaching 0. So if the limits on both of these are approaching 0, then that means this is going to have to approach 0, right? Because this value is in between those two values. So then by the squeeze theorem, the limit as x approaches sine x over the square root of x is, where that's going. sine as x goes to infinity of the sine x over square root of x is going to be approaching 0 as well. So this value is going to be approaching 5. It's just a constant. This is going to be approaching 0. So our overall limit is going to be 5. Right. So, and then just a couple little properties before we kind of throw them into the next is that if we have polynomials, we're talking about powers, we're plugging powers in. If the limit as x approaches positive or negative infinity x to the n, it's going to be an infinite, right? Because you are, if you have an even power, really we're kind of talking about evens and odds, and we're going to organize them on a different chart. We're going to put all these pieces together. You have stuff that your graph, your end behaviors are looking like that, or they're both going down. If you have an odd, then potentially you got going up in one direction, down in another direction. If you remember that from your pre-calc stuff. Rationals, we have a tendency to our graph kind of levels off on either side, if you remember that. So we're approaching 0. Pretty common, especially if the power in the denominator is bigger than the power in the numerator. And then if you have a value in the front, it may flip stuff, it may kind of change some direction. So we'll organize all of that and we'll talk a little bit of review from a pre-calc on the next problem.